In Chapter 11, we're going to be working with probability. And in 11.1, we're going to be working on probability and odds. So one of the things we want to be able to do is to find sample spaces and probabilities. And our key vocabulary here is going to be outcome, event, sample space, probability, and odds. Okay, now when we talk about conducting an experiment, anytime you conduct an experiment, any possible result of that experiment is called an outcome. So for example, if I roll a number cube or a one of a pair of dice, there are 6 possible outcomes: 1, 2, 3, 4, 5, or 6. Okay, so these are the possible outcomes, and an event is an outcome or a collection of outcomes, such as rolling an odd number. So if I wanted to look at, I might want to calculate the probability of getting an odd number when I roll a dice. And the set of all possible outcomes is called a sample space. So if we wanted to look at defining a sample space, if I were to flip a coin and then roll a number cube, how many possible outcomes are in the sample space? We want to list all the possible outcomes. And one of the ways that we might go about this is we might use a tree diagram. So for starts, we're going to flip the coin. And that could come out heads, or it could come out tails. So I've taken my first event, right, the flipping of the coin, and it has 2 possible outcomes, heads and tails. As I continue on, next when I roll the die, I'll have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's not just going to happen one time. That's going to happen twice, right? It can happen after I've rolled heads, or it can happen after I've rolled tails. And so you can see that my total the total number of outcomes there are 12. And this is my sample space. I can roll heads and then a 1, heads and then a 2, and so on. Or tails and a 1, tails and a 2. And when we talk about probability, probability is calculated by finding the number of favorable outcomes over the number of total possible outcomes. And this is called theoretical probability. We're not actually conducting an experiment, we're just looking at the situation and we're finding out what might happen. Okay, for example, if we go to the previous example and say, well, what's the probability of rolling a head followed by a 1? Well, head followed by 1, there's only one positive favorable outcome, but there are 12, as we've already identified, possible outcomes to flipping a coin and rolling the dice. Okay, that would be theoretical probability. And the way you would write the probability of event A is the probability, or in parentheses, A, close parentheses. So P stands for probability and A is event A. So if me and my friends have designed some t-shirts with certain silkscreen emblems and we're selling our t-shirts to raise money, we have this table below here, and you see that we've got green t-shirts and red t-shirts, and then on those t-shirts we put silver and gold emblems. So there are 4 different possible outcomes. I could have a green t-shirt with a gold emblem, green with silver, red with gold, red with silver. So if a student chooses a t-shirt at random, what's the probability that they choose a red t-shirt? Well, the total number of red t-shirts would be 6 gold and 6 silver. That would be 12. Out of a total of those 12 plus another 18, which would be 30. So 12 out of 30, which when simplified will be 2/5, or typically we express probability as a percent, 40%. Okay, and equally I could look at what's the probability of getting a green t-shirt with a silver emblem. That would be 8 out of 30. Or a green t-shirt with a gold emblem, that would be 10 out of 30. Okay, so we can use the table to help us in this case. And this is, again, like a two-way frequency table like we made before in chapter 10. And now we're going to use it to calculate probability. Experimental probability is based on actually conducting repeated trials of an experiment. Okay, so remember what we looked at before was theoretical probability. We're just looking at what's possible, but we're not actually doing anything. We're just talking about it. It's all in theory. Experimental probability is based on repeated trials of an experiment, and the number of trials is the number of times the experiment is performed, and each trial in which a favorable outcome occurs is called a success. So in experimental probability, we're talking about the number of successes over the total number of trials. Okay, so for example, here we're talking about spinning a spinner. If I talked about this as theoretical probability, the likelihood of any one color coming up is 1 in 4 or 25%. Okay, that's theoretical probability, but what's happened is the spinner was spun 20 times. So, all right, we spun it 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as theoretical probability? Okay, so how many do we need in order to have 1 in 4? Well, you can see if I cross multiply this, if I make this x, I'll get 4x is equal to 20. So the number of successes I would need would be 5. So that would be A, red. Okay, so what I did to do this is I knew what theoretical probability is. This is theoretical probability. And then I have to find out what experimental probability would match this. Equally, you could look at, well, to turn 4 into 20, I have to multiply it by 5, so I have to multiply the 1 by 5. That would be another way to work through this. Okay, so I instead set up a ratio and solved my ratio for the unknown value of how many successes do I need to make it match. Okay, and when we talk about odds, it's similar to probability in that the number of favorable outcomes typically goes in the numerator, but the denominator is the number of unfavorable outcomes. So instead of the total outcomes, right, so odds in favor are favorable outcomes over unfavorable outcomes. Odds against are unfavorable outcomes over favorable outcomes. So when we talk about the odds against stopping on green, we'd have the number of unfavorable outcomes, that's 3, blue, red, and yellow, and the favorable outcomes is 1. Okay, so this is, odds are typically expressed this way, 3 to 1 against. Okay, and that's a quick overview of probability and odds.